In this example, we're going to use the equation of continuity for laminar fluid flow to help us calculate the number of capillaries found in the human body. Now, before we begin with the example, let's recall a bit of physiology. The lungs found in our body play the role of oxygenating our blood, and then that oxygenated blood travels to our heart. Now, the heart is an organ found in our body that plays the role of the pump. It pumps all that oxygenated blood to the rest of the tissues and organs found in our body. So the blood begins in the heart and travels through a single blood vessel known as the aorta. And then that aorta divides and subdivides into many different smaller blood vessels known as capillaries. So capillaries are the smallest possible type of blood vessels found in our body. And in fact, it is within the capillaries that oxygen exchange and waste and nutrient exchange takes place between the organs and tissues and our blood vessels. So, let's begin by looking at the given information. In the human body, the radius of the aorta is about 1.2 centimeters and the blood passing through has a speed of 40 centimeters per second. A capillary, however, has a radius of 4 times 10 to the negative 4 centimeters and the velocity passing through it is 5 times 10 to the negative 2 centimeters per second. Now, approximately how many capillaries are found in our body? So, we begin by making two important assumptions. Assumption number one, the density of the blood within our blood vessels does not actually change, it remains constant, and our blood experiences laminar flow. Using that, we can use our continuity equation. Now, the continuity equation states the following: that the volume flow rate through our aorta is equal to the volume flow rate through all the capillaries combined. Now, that basically means the following: the product of the cross-sectional area of the aorta and the velocity of the blood through the aorta is equal to the product of the sum of all the cross-sectional areas of the capillaries multiplied by the velocity of blood through a single capillary. Now, we're assuming that the velocity of blood within every single capillary is exactly the same. And we're also assuming that the cross-sectional area of each capillary is also the same. Using those assumptions, let's begin our problem. So notice our cross-sectional area of our aorta is simply, well, because we have one aorta, that means it's pi times radius of this aorta squared, multiplied by the velocity of blood through this blood vessel. And that is equal to, well, now we're dealing with many different capillaries. And because every single capillary has the same exact cross-sectional area, let's suppose the cross-sectional area of a single capillary is pi r capillary squared. Now, because we have some unknown number of capillaries, to find the total cross-sectional area, I have to multiply this single cross-sectional area by the number of capillaries. So let's say the number of capillaries is given by capital letter M. So I multiply this by M, and this gives me the total cross-sectional area of all the capillaries combined. Now, we multiply this by the velocity of the blood through a capillary. Now, we know what this quantity is, we know what this quantity is, and these two quantities. So that means we can solve for M. M is equal to, notice the pi's cancel, so we're simply left with the product of the radius of the aorta squared and the velocity through the aorta divided by the product of our velocity of the capillary and the radius of the capillary squared. So, notice our velocity aorta is simply 40 centimeters squared. So to convert that to meters squared, divide that by 100. We get 0.4 meters squared. What about our radius squared? Well, the radius squared is simply 1.2 centimeters divided by 100, so 0.012 meters squared. And the bottom becomes, well, I take each respective quantity and I divide it by 100 to convert it from centimeters to meters, and I get the following two quantities. I multiply, divide, and I get about 7.2 times 10 to the 9 capillaries in the body. So approximately there are about 7 billion capillaries found in our body.